Hey guys, today's Math Helper is on lesson 6 for Module 2. We're talking about area model and multi-digit multiplication. Um, Today, basically what we have is we're kind of extending the area model out from, and we're going to decompose numbers down a little bit further to make it easier as we start getting up higher and higher into our digits of multiplication. So what we're going to do is I have a couple problems for you. And, whoa, hi there. A couple problems for you, and we'll talk about them as we go. So first problem would be 64 and 73. And what we take a look at this, we'll use 73 as our unit. So what I want to do is I want to draw an area model. Okay, and remember area, we're trying to multiply one side times the other side to find the area. If I put my 73 up here, how many 73s am I looking at doing? I'm looking at 64 73s. And how can I decompose my 64 to make it easier for me to multiply by 73? I can split it up. I can take my 60 and I can take my 4, and that would make my life a lot easier. So I'm going to do that. I'll take 60 and I'll put my 4. And I can do 60 times 73 and 4 times 73. Now, when I do look at that, though, I see, my 73 and my 6, and 6 times 73, it's a little tricky to do in my head. So what can I do to make my life easier on here? Well, I took apart my 64 to make life easier so that I can multiply that. So I could also decompose my 73. And if I did something like that, well, let's take that apart. If I did that, that would be 70 and 3, right? Same way I did it here. So I would need to make sure that then I am leaving myself some space to do that. And so now I have myself an area model that makes it a little easier for me to multiply. And so what I'm going to do then is I'm going to multiply each of these numbers, because that's why I have a box here. This box here is for my 4 times my 70, okay? And 770, or 7 times 4, is 28, or 280, because it's 70. 4 and 3, 4 times 3 is going to go in here, and that's 12. I've got 60 and 70. Now, 6 and 7 is 42. And 60 and 70, that leaves me with 2 more zeros. That's definitely 4,200. And 60 and 3, well, 6 and 3 is 18. And 60 would make that, so 180. So now I have all my little totals here. And what I would need to do is add them up. So let's start doing that. Let's add them here, a little algorithm. 4,200. I want to make sure these are all lined up nicely on top of each other. 280, 180, 12. Got myself a nice little math tower here, and I can come down. That's 2. 8 and 1 is 9, and 9 and 8 is 17. 2 and 2 is 4, and 1 is 5. Another one is 6. And I have 4. So I get a product of 4,672. Now, what I want to do is take a look at multiplying this as far as using a standard algorithm goes. So let's do that. Let's take 73 and multiply it by 64 times. And let's do this. Let's work this out. I have 4 and 3. 4 and 3 is 12. And so as I write this, I'm going to think 4 and 3 is 12. I'm going to put 12. So let's see how my 12 is there. 12. And if I look over here, what do I have? Bingo, I have 12. And that's my 12 there. 12 and 12. See, 4 and 3, 4 and 3. Now I have my 4 times my 70. 4 times 70. 70 times 4, 4 times 70. 7 times 4 is 28. And I have that, plus I have my one from here, my 10. So that's 290. So 292. And if you go ahead and take a look, if I had 280 plus 12, well, that would also equal 292. So I have this here is the same as right there. Okay. Now let's do my 6. 60 times 3. Remember, it's not just 6. 60. 60 times 3. Well, that's 180. I'm going to do the same thing I did before. I should cross that guy off because I'm not using him anymore. 180. And see how I do this? 6 times 3. I got my 180 there. 60 times 70. 60 times 70. Well, that's 4,200. Plus my other one here is 4,300. Or 6 and 7 is 42. Plus 1 is 43. 4380. If I notice down here, my 4,200 plus my 180, well, that equals my 4380. So this here is also over here. Now all I have to do is add them up. 2, 7, carry my 1, 6, 4. So I have the same product for both of these. The reason that I go about connecting this side to this over here is to show you that the way this process works, kind of behind the scenes. Like if you could peek behind something and see how something works. Well, that's what we're doing. We're peeking behind a standard algorithm to see exactly what's going on and why it works that way. Okay, so let's go ahead. Let's kick things up a little bit of a notch, and let's go with 814 multiplied by 39. Okay, and now obviously I'm doing hundreds here instead of just in my tens. So what I'm going to do is when I make my area model, I'm going to make it just a little bit wider, because that'll give me enough room to decompose my 814. Okay, so we're going to decompose both of these numbers. Let's just start with the 814 because it's there. If I take that apart, I have 800, I have 10, and I have 4, right? 800, let's put that first. 800. Give myself some section there. 10. Remember, I did 10 because that's what my 1 represents. I'm decomposing this. And 4. And 810 and 4 is 814. And then I have my 39. Let's do the same thing. I have 30 all the way across, and I have 9. And then I'm just going to do the same thing. I'm going to go ahead and multiply this times this, and this and this, and this and this, and multiply this times this, and this times this, and this times this. Well, let's try. 9 and 8, 72, with my 2 zeros. 9 and 1 is 9, or 90. 9 and 4 is 36. Let's come down here and do my 3. 3 and 8 is 24. Plus 1, 2, 3 zeros. So 24,000. Does that seem right to you? 800 times 30? Yeah, that seems about right. 24,000. I've got 30 and 10. So that would be 300. And I've got 30 and 4. Well, 3 and 4 is 12. That's my 0 on it. Now I have all those. And I need to add them up. Let's start on the bottom. 24,000. Go with my next biggest one, 7200. And then 300. And then 120. And then 90. And then 36 as my tower gets really tall. No, not multiply. The heck, buddy. And I'm going to add all of these up to find my product. 6. 9 and 3 is 12, and 12 and 2 is 14. 2 and 5, 3 is 5, 6 is 7, 7 and 4 is 11, and 1 and 2 is 3. I'm saying my product is 31,746. If I went ahead and estimated that, 800, it's about 800, and that's about 40. And 800 times 40, be 32, about 32,000 is a good estimate. And I think I'm right on. I got about 32,000, so that's a good deal. Now, what I want to do is I want to take a look at that in my standard algorithm, and so I'm going to go ahead and I'm going to write that next to this in a separate color. If I do 8, 14 multiplied by 39, 9 and 4, there's my 36. There's my 36. 9 and 1, or 9 times 10. 9 and 1 is 90. 9 and 10 is 90. Plus my 3. 9 and 1, 90. 100. 110, 120. 9 and 8 is 72. Plus 1, 73. So I have my 7326. If I added all of these up, I would have 7326. See, that's these ones right here. Because what did I do? I just multiplied 9 times 814, right? 9 times 814. Okay, so now I have to do my 30 times 814, right? My 30 times 814. Well, 30 times 4, so here it is, 30 times 4. It's 120, so 30 times 4 is, I should cross these guys off so I don't get confused. 120. 3 times 1 is 3, plus my other one is 4. 3 times 8 is, here's my 3, here's my 8, 24. 3 and 8 is 24. Now I'm adding up. 6, 4, 7, 1, carry my 1, 3. 31,746. You can see how it all works out. Here's the deal with this whole thing and this area model and our algorithms. If you can multiply any digit 1 through 9, 0 through 9 really, if you can multiply any of those digits by any other digit, you should be able to do this no problem. Because when we decompose like this, all we're doing is taking it down to a single digit by single digit multiplication, right? When I put it down into an area model here, all I'm doing is doing 9 times 8. All I'm doing is 9 times 10. All I'm doing is 9 times 4. And over here, ultimately, that's all you're doing too. Don't let all these other numbers that are in a standard algorithm fool you. Don't let them get to you. If you're doing something like 648 times 35, well, just take it one number at a time. Take it 5 times 648 first. Do that first. And then take it where you're doing 30 times that. And that's ultimately all we're doing, and then we're adding it up. I hope you're rocking this out. I hope you don't have any issues with this, but if you do, certainly come to class with some questions or post them in the comments, and I'll try and help you out. Practice on this makes perfect. Perfect practice makes perfect. And that means that, if you're going to come up and you're going to see a problem and it's going to be tricky for you, well, then you're going to have to work at it. You're going to have to solve a whole bunch of them before maybe you start feeling confident in yourself, confident in your abilities. But you're certainly not going to do yourself any good, and you're certainly not going to get any better if you don't get out and try something. And that doesn't just go with math. It goes with everything in this world. If there's something that you want to get better at, there's something that you want to do, then you need to work at it. And certainly being intelligent and knowing how to solve problems And certainly knowing math facts and basic multiplication are things that you want to know. You want to have this down in your life. So practice and work at it. And when you're all done, check your answer and make sure it makes sense. And if it doesn't, ask somebody. Um, and you guys are awesome. You're super smart, and you're great people. So keep up the hard work. Okay. All right. See you later.